Hi, welcome to PowerFlick. So our question is, we need to find the resistance by seeing this graph. So in order to get the resistance through a graph, we need to convert our equation, Ohm's law equation, into a straight line. For example, Ohm's law is V equals to I R, right? Here V is x-axis. So this is x-axis and I is y-axis. So what I do is I'll keep I this side and I'll write 1 by R to. So if you observe, this equation is like same as y equals to mx, right? Y equals to I, V equals to x, and m is R. M is nothing but slope. So when you are having IV characteristics, in IV characteristics, slope of the curve is nothing but 1 by R. This is the point which need to be remembered. Now, these are the three IV characteristics of some component. I will also discuss what component it is, but these are the IV characteristics of some component whose slope will be equal to 1 by R. We are going to find the slope, and from that we'll get the value of R. Now, this is the plot one. So we are having current here. This is I and this is V. So in order to find the slope, we need to find the slope of this. I'll take 2 points, this point and this point. So this point can be written as x1, y1. So the x1 is 2 and I'll write it as 2, 0.02, which is x2, y2. This one is minus 2, minus 0.02. This one is x1. So we have x1, y1, which is minus 2, minus 0.02, and x2, y2, 2, 0.02. Now slope m of this line will be y2 minus y1 by x2 minus x1. So y2 will be 0.02 minus of y1 be 0.02 by x2 2 minus x1 minus 2. So m, which is nothing but 1 by r, is equals to 0.02 plus 0.02 by 2 plus 2, which is equal to 0.04 by 4. So this can be written as 4 by 100, this I'm writing, divided by 1 by 4. By 4 cancel, it is 1 by 100. Therefore, 1 by R is equals to 1 by 100. 1 by 100, R is equals to 100 ohms. So the R of this, R is equals to 100 ohms. We got R equals to 100. We can re-verify it also. For example, R is equals to 100. So the equation will be I equals to V by 100. Simple. This will be the equation. Like Y equals to mx and m equals to 1 by 100, right? So from here, we got this equation. Now I consider this one, okay? Y. Y means I. V is equals to minus 1. So we keep minus 1 by 100. So what is I? is equals to minus 0.01 and minus 0.0. Got it? If you are having a linear curve, then 1 by r will be the slope of it. This linear curve, you may ask why it is not y equals to mx plus c. Why you have considered only y equals to mx? Usually in a component, say resistance like this, sorry, usually in a component like resistance, if V is equals to 0, if there is no voltage drop across it, there won't be any current flow. V, if it is not there, there won't be any current flow. Therefore, the point will be 0, comma 0. So the equation should be passing through origin. That is why we have taken the equation I equals to V by R as y equals to mx. There is no intercept. Y-intercept is absent here. This is intercept. That's why we are considering this. Similarly, the next plot. This is the next plot. This is the plot. We are having a straight line. Usually, this is the plot. For this, this is the plot. Okay. So here it is clear that this plot will be y equals to c plot. Okay. So here y is nothing but I and c is nothing but 0. Clearly see here 0, 0. It is going through 0. It is going to 0 here. So here we can write it as I equals to 0. So if we compare this with I equals to 1 by R into V, okay, I equals to 0 and V, this is equals to 0. V, if you see, there is one point when V is 0, but other points are non-zero. So we can consider this as V is not equals to 0. So there is a point 0 equals to something x, okay, into some, this V is not equals to 0. V is not equal. So here we need to consider x as 0. This is how it works. Left hand side it is 0. Right hand side you are having multiplication and one parameter is not 0. You are sure from the plot. Then the other parameter must be 0. That is how it works. According to this, now from the slope and the discussion, we can consider it as 1 by r is equals to 0. And if it is so, r is equals to 1 by 0, which is infinity. So here, for the second plot, r is equals to infinity. Got it? Third plot. Coming to the third plot, it is very clear that y equals to 0. Sorry, v is equals to 0, right? So v is equals to 0. At this point, I is equals to 0. Only at this point, I equals to 0, but others, I is not equals to 0. Sorry. Next plot. Here, we are having v is equals to 0 and it is constant. From the plot, we can say v is equals to 0. And I is non-zero component. So like the same thing, I equals to 1 by r into v. I is something which is not equals to 0. Okay, not equals to 0 and 1 by r into v. So here v is 0 all the time. Is 0 all the time. So how I'll write is I into r, which is equals to 0. As already discussed, I is not equals to 0. So r should be 0, right? Therefore here r equals to 0. Now, what components will have this type of characteristics? Usually, resistance, resistor will have this type of characteristic. So the component is resistor. Resistor will have this, and resistor having 100 ohm resistance will have the VI characteristics like this. Next, R equals to infinity, you should consider it as a switch. Okay, you have to consider it as a switch. Switch, particularly it as a open switch. And this one, this is a this is also a switch, but it is a closed switch. Closed switch. So whenever you see a resistor, V equals to IR, this should be the equation. You need to get this need to get into your mind. And when it is an open switch, you need to understand that R is equals to infinity. Since R is very large, that it is equals to infinity, there is no current flow. Since R is very large, very large, we are not having current flow here. Closed switch. Closed switch, if it is a closed switch, the resistance of the switch need to be considered as 0, and the voltage across the switch will be considered as 0. So if it is an open switch, current will be 0, R will be infinite. If it is a closed switch, R will be 0 and voltage will also be 0.